To identify lead connections on an unlabeled 6-lead motor, you can use an ohmmeter. Firstly, connect the ohmmeter between 2 of the 3 untied leads. Secondly, if the resistance is low, typically below 10 ohms, these are 2 line leads. Thirdly, repeat the process with the remaining untied lead. The 2 leads that show low resistance when tested against the 3rd lead are also line leads. Fourthly, the 3 tied leads are the neutral or common leads. If the motor is a 6-lead Y start delta run configuration, you can wire it for delta on 230 volts as follows. 1. Identify the 3 line leads from the above steps. 2. Connect 1 line lead to each of the 3 terminals of the delta power supply. 3. Connect the 3 neutral leads together and tape them off. Operating a 440 volt delta design motor on 230 volt delta will result in low speed and torque. Ensure the motor's nameplate specifications, including voltage, current, and power, are compatible with the 230 volt delta supply. Exercise caution when working with 3-phase electrical systems, as improper connections can damage the motor or create safety hazards. To further elaborate on identifying the motor leads with an ohmmeter, it's important to understand what you are looking for. A typical 3-phase motor has 3 sets of windings, each corresponding to one of the 3 phases of the power supply. In a 6-lead motor configuration, each winding has one end brought out as a line lead and the other end connected to a common point, which results in the 3 neutral leads tied together. When using an ohmmeter, you are measuring the resistance of the motor windings. The resistance between 2 line leads will be the combined resistance of the 2 windings connected between those leads. The resistance between a line lead and a neutral lead will be the resistance of a single winding. Because the windings are made of copper wire, the resistance will be very low, typically a few ohms. When you measure between 2 untied leads and find a low resistance, it indicates that you are measuring across 2 windings connected in series. This confirms that those 2 leads are line leads. Repeating this process with the remaining untied lead allows you to identify all 3 line leads. The 3 leads that are tied together are the neutral leads, as they form the common point of the Y connection. When connecting the motor for 230 volt delta operation, you are essentially reconfiguring the windings from a Y connection to a delta connection. In a delta connection, each winding is connected directly across 2 phases of the power supply. To achieve this, you connect each line lead to one of the 3 terminals of the 230 volt delta power supply. The 3 neutral leads, which were previously connected to form the common point of the Y connection, are now isolated and taped off. It's crucial to ensure that the motor is suitable for 230 volt delta operation. The motor's nameplate will indicate the voltage and connection type for which it is designed. If the motor is designed for 440 volt delta operation, operating it on 230 volt delta will result in a reduction in both speed and torque. This is because the voltage applied to each winding is lower than the designed voltage. The motor will still run, but it will not perform as efficiently or produce as much power. It's essential to consider the application for which the motor is being used. If the lower speed and torque are acceptable, then operating the motor on 230 volt delta may be a viable option. However, if the motor is required to deliver its full rated power, then it's necessary to use a motor that is specifically designed for 230 volt delta operation. Safety is paramount when working with 3-phase electrical systems. Always disconnect the power supply before making any connections. Use appropriate safety equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electrical systems, it's best to consult a qualified electrician. It's also good to note that the information provided assumes a standard Y start delta run motor configuration. While this is a common configuration, there are other possible configurations. If you are unsure of the motor's configuration, it's best to consult the motor's nameplate or a qualified electrician. Furthermore, when connecting the motor, make sure to use appropriately sized conductors and connectors. The conductors should be rated for the voltage and current of the motor. The connectors should be properly installed and tightened to ensure a secure connection. Loose connections can cause arcing and overheating, which can damage the motor or create a fire hazard. After making the connections, it's important to test the motor to ensure that it is running correctly. Use a voltmeter to verify that the voltage at each terminal is within the acceptable range. Use an ammeter to measure the current draw of the motor. The current draw should be within the motor's rated current. If the voltage or current is outside of the acceptable range, there may be a problem with the connections or the motor itself. In this case, it's best to consult a qualified electrician to troubleshoot the problem. Remember, working with electrical systems can be dangerous. Always take the necessary precautions to protect yourself and others. If you are unsure of anything, it's best to consult a qualified electrician. To summarize, identifying the leads of a 6-lead motor involves using an ohmmeter to measure the resistance between the leads. The 3 untied leads that exhibit low resistance between each other are the line leads, and the 3 tied leads are the neutral leads. Connecting the motor for 230-volt delta operation involves connecting each line lead to one of the 3 terminals of the 230-volt delta power supply and isolating the neutral leads. It's crucial to ensure that the motor is suitable for 230-volt delta operation and to take all necessary safety precautions when working with electrical systems. Remember to always consult the motor's nameplate for voltage and connection specifications. If the motor is designed for 440 volts delta, operating it on 230 volts delta will result in a reduction in both speed and torque. Consider the application for which the motor is being used and ensure that the lower speed and torque are acceptable. Use appropriately sized conductors and connectors when connecting the motor. Verify the voltage and current after making the connections. If you are unsure of anything, consult a qualified electrician. By following these steps, you can safely and effectively connect a 6-lead motor for 230-volt delta operation. Also, note that the insulation resistance of the motor windings should be checked before energizing the motor. This can be done using a megameter, also known as a megger. The megameter applies a high voltage to the motor windings and measures the resistance between the windings and the motor frame. A low insulation resistance indicates that the insulation is damaged and the motor may be unsafe to operate. The megameter reading should be above a certain threshold, typically 1 megohm or higher, depending on the motor's voltage rating. If the insulation resistance is low, the motor should be inspected and repaired before being put into service. In addition to checking the insulation resistance, it's also important to visually inspect the motor for any signs of damage, such as cracked insulation, loose connections, or corrosion. Any damaged components should be replaced before operating the motor. Proper maintenance of the motor can help to extend its life and prevent unexpected failures. This includes regularly cleaning the motor to remove dirt and debris, lubricating the bearings, and checking the connections. It's also important to monitor the motor's temperature and vibration levels. Excessive temperature or vibration can indicate a problem with the motor. If you notice any unusual noises or smells coming from the motor, it should be inspected immediately. When working with electrical equipment, it's important to be aware of the potential hazards and to take the necessary precautions to protect yourself. Always disconnect the power supply before working on any electrical equipment. Use appropriate safety equipment, such as insulated gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. If you are unsure of anything, consult a qualified electrician. Furthermore, before connecting the motor, check the rotation. If the rotation is not correct for the equipment that it will be powering, reverse any 2 of the 3 motor leads. Finally, it is often a better solution to source a motor that is designed for the 230-volt delta system rather than reconfiguring an existing motor that may not be suitable. This will ensure optimal performance and avoid potential problems caused by undervoltage. Also, use a motor starter with overload protection. The overload protection is designed to protect the motor from overheating due to excessive current draw. The overload protection should be sized appropriately for the motor's full load amps. If the motor is overloaded, the overload protection will trip, disconnecting the power supply to the motor. This will prevent the motor from being damaged. Consider using a variable frequency drive, or VFD, to control the motor's speed. A VFD allows you to adjust the frequency of the power supply to the motor, which in turn adjusts the motor's speed. This can be useful for applications where you need to vary the motor's speed. A VFD can also improve the motor's efficiency and reduce energy consumption. However, VFD can be complex to install and configure, so it's important to consult a qualified electrician if you are not familiar with them. If the motor is located in a hazardous location, such as an area where flammable gases or vapors are present, it's important to use a motor that is specifically designed for hazardous locations. Hazardous location motors are designed to prevent sparks or other ignition sources from escaping the motor and igniting the flammable atmosphere. When replacing a motor, it's important to choose a motor that is compatible with the existing equipment. This includes matching the motor's voltage, horsepower, speed, and frame size. It's also important to consider the motor's enclosure type. The enclosure type determines the motor's protection against environmental factors such as dust, water, and corrosion. If the motor is located in a harsh environment, it's important to choose a motor with an appropriate enclosure type. When disposing of a motor, it's important to follow all applicable regulations. Motors may contain hazardous materials such as oil, mercury, and lead. These materials must be disposed of properly to protect the environment. Contact your local waste management agency for information on how to dispose of motors properly. Proper selection, installation, and maintenance of three-phase motors are essential for ensuring reliable and efficient operation. By following these guidelines, you can help to extend the life of your motors and prevent unexpected failures. Remember that safety is always the top priority when working with electrical equipment. Always disconnect the power supply before working on any electrical equipment and use appropriate safety equipment. If you are unsure of anything, consult a qualified electrician.